Hey everybody, today we're going to be talking about WebSockets in Actix Web as well as the Actor framework in Actix Web. The reason why we need to talk about those two together is because WebSockets in Actix Web heavily use the Actor framework. This is different than regular Actix Web because you can code an Actix Web application in full without ever having to worry about an actor. With WebSockets, you have to know what actors are and what they do because each socket is an actor. A little bit about the actor pattern. You can think of actors as components that have mailboxes. These mailboxes can contain messages which the actors respond to. The reason why this is so powerful is because actors work entirely independent of each other. This means that an actor can be running on a different thread or a different machine entirely, just as long as they can respond to those messages properly. Okay, I think we're ready to go code the project. So all you have to do is run your cargo init. These are the 4 dependencies we'll be working with: Actix Web, Actix Web Actors, Actix, and UUID. I recommend running a cargo run after you include all this in your cargo.toml because this might take a little bit to compile all those crates that we just added. After you compile all the packages and ran the hello world, which might take a couple minutes, we now create a new file called ws.rs. This is where our socket actor will live. First up, we're going to add all these imports. Take a minute to pause the video. We'll be writing these imports in a bit, so you're going to get an error here, as well as these imports, which will also get an error. But all the other imports should work perfectly fine. As always, we need to mod in ws. Now we'll see those errors that we talked about. We'll also need some constants. These are for something in the future. We'll just have them up here for right now, just so we don't forget about them. Okay, so we're going to write a plain old Rust struct, and we're going to call it WS connection, or WSCon for short. We're going to have 4 different fields. One is going to be the room, which is going to be a UUID. This is the room in which this connection lives. It's going to, when a connection sends a message, it's going to send it to everybody in the room, and he's going to only see messages from people in his room. That way, instead of having everybody being in one big chat room, we could have a bunch of different chat rooms with different topics or whatever you decide you want to do for your use case. The next thing we're going to do is have a lobby address, which is an address of the lobby. In the actor framework, you actually don't pass around references to structs or the actual structs themselves. You pass around addresses to that actor. So in this situation, lobby has to be an actor, or else this would error out. What you can do with an address is you can send messages to that address. That's really useful because we need to be able to send messages to the lobby so that the lobby can echo that out to the other sockets. If each connection had every other connection, you'd have an n² problem where you'd be storing addresses on every single connection to every single other connection. So having this lobby here makes that a lot easier and a lot more maintainable. The next thing we're going to have is HB, which stands for heartbeat, and it's just going to be an instant. An instant, if you don't know, is just a moment in time. The reason why we have this here is because we need to do something called heartbeating the WebSocket connection. Sometimes WebSocket connections close without giving close messages to the server. In this case, we don't want to have this WebSocket connection sitting around without us ever knowing that it's actually dead. That it would clog up our server, and we don't want that. So with this heartbeat instant, we're going to start a loop a little bit in the future where we send a message to the client, and the client is going to send back a message every single time that mimics the message that we sent. If we send a message and the message never comes back, that means that our heartbeat failed and we need to terminate this connection. Finally, we have our own ID, which is a UUID, and that is just how this connection will identify itself to the lobby. And just for convenience sake, we'll have a new method without having to worry about adding the heartbeat or the ID of the connection. Now we're going to be making this connection in actor. As you can see, this is just a plain old Rust struct with no traits or anything like that. But we still need to be able to do actor things with this connection. So we're going to implement the actor trait for the WS connection. And you can instantly see here we have some errors because we're missing the context variable. So we're going to do type context is equal to WebSocket : WebSocket context of type self. Each actor needs a context, which is where that actor lives. In this case, we live in the WebSocket context, which means we can do WebSocket stuff. We're going to have an example in the future where we actually just create our own context that is just a generic context with no other stuff tied to it. But in this case, we need to be able to do stuff like start the WebSocket and send messages through the WebSocket, which is why we use this WebSocket context from Actix Web actors. In this actor trait, we have lifecycle methods for the actor. There's started, running, stopping, and stopped, where stopped happens after the actor has been killed. Stopping happens before the actor has been killed. And started happens when the actor has started. And running is after the actor has started. We're only going to be implementing 2 of those. We're going to be implementing the started, and we're going to be implementing the stopping. As you can see, we actually need some parameters here. So we're going to be taking a mutable reference to ourself. And we're also going to be taking a context, which is going to be just this up here. It's going to be a WebSocket context of yourself. And that context is also going to be a mutable version of that. So what do we need to do in this started method? Well, first we need to start the heartbeat process, which we will code in a little bit. And we just need to pass that context here. What we need specifically in this heartbeat, the reason why we're passing this context, because this context object can do things to this actor, like stopping it, which is exactly what we need to do in this heartbeat method. If the client doesn't echo back the heartbeat message, we need to be able to stop it, which is why we need this context object. Next, let's define a variable called address, which is going to be the address from the context. With this address, we can pass it around to whoever needs to send us messages. In this example, it'll be the lobby that needs to send this actor some messages. So we're going to go self.lobby address, and we're going to .send it a message, which is going to be a connect message. And that connect message is going to have an address, which is the address.recipient. And we're going to code this struct a little bit in the future. But right now, we're just going to not worry about these errors here. This will all check out in the future, I promise. And now everything else we do is just plain old Rust here. We do lobby_ID. We need to pass the room. And self_ID. We want to pass the self.id. And so what happens here is this is the first message sending we have coded here. This is going to put a connect message in the mailbox of the lobby. But you can see here that we actually have send, which sends an asynchronous message and waits for a response. This is in contrast to the doSend method, which would send the message synchronously and just not care about anything else. By synchronously, we don't actually have to wait for that message to get handled. We just basically throw the message at the mailbox, and that's it, and just drive away and just keep doing our thing. But in this case, we do actually care about this message going through, because if it doesn't, that means our connection couldn't have been established. So we want to go dot into actor. We want to make this response an actor. And then we want to take the response. We don't care about this parameter. And we want to take the context. And we want to match on that response. If it's okay, then we just don't care about it anymore. But if it's not okay, or if it's anything else, we just want to stop the context because something failed, and that's not good. After this, we want to say that whatever process after this match executes, that means that this has responded to the message, and we can say that we are currently ready to do the next step. And then we're going to wait in this actor's context, which means that we are going to just wait for whatever happens here. This actor will not do anything else until this process is completed. All we do is we send a connect message to the lobby, and then we wait for the response. Now we need to write this stopping method, which has the exact same signature as the started method. In fact, all the lifecycle methods have that same signature. And we're going to copy and paste that in there. But this time, we're not going to actually need the context at all. We really don't care about having that context, so we're just going to underscore it. We need to return a lifecycle state here. And in this case, we'll just return running, which is just an enum that has all the different lifecycle states that can be performed when it is running. Because we're stopping, we want to return a running stop. We want to force it to stop. If we did a running continue, we would try to keep it alive, but that would not do anything in this context, because if this gets triggered, that means the client shut down their connection, and keeping it continuing would not be something that we really want. We want to also send a message to the lobby, but this time, instead of doing it asynchronously, we want to do it synchronously. We want to send a disconnect message with an ID of self, just let them know who is disconnecting. And we also, just for convenience, want to tell them what room we're in. The next thing we can do in this file is implement the heartbeat. This is going to be mostly just pure Rust and a little bit of instance, but there is one cool little thing that I think we need to make note of. This is just going to be a function on the WS connection. It's going to be called heartbeat, and that's up here. And you can see in that signature up there that we're going to take ourself, a reference to ourself, and context, which is a mutable reference to the WebSocket context of self. And we're not going to return anything here. But we're going to take that context. We're actually going to run an interval. And it's going to be heartbeat interval. That is what we defined up there. So this method is going, whatever we pass in here is going to run every single heartbeat interval. In this case, it'll be every 5 seconds we'll ping the client. Depending on your project, you might want to do that more or less. In a simple chat room, 5 seconds is perfectly fine. For the function, we're going to get two parameters here that we want them both. They're going to be the actor itself and the context again, because here we consumed the context. If instant.now, since the actor heartbeat, actor is this self, so we actually have access to this instant through this actor that we pass to it, is greater than the client timeout instance, which means that if we send a message, if we send a heartbeat and we don't get a response within 10 seconds, we want to do something here, which is we're going to print disconnecting due to failed heartbeat. And now we're actually going to want to send a disconnect message to the lobby. The same exact way we did it up there. And there you go. We sent that disconnect message to the lobby. And we also want to stop in the context. And that'll just force it to stop. And then we just return. But outside of this, we want to context.ping in bytes, because a ping message is a byte. We want to just ping it like that. And that's it. We just add a semicolon here. And all our errors clean up. And now we have a working heartbeat method. You see that we still haven't defined the lobbies or the messages. And this is still an error because this address does not implement the handler for this message, but we are going to do that in the future, so don't worry. We're going to implement a stream handler of type results, ws : message, or the protocol error, which just means that there is some mistake in the WebSocket protocol. But this would actually be, if it is a OK value, then it would be just the message. If there's an error, it'll be the WebSocket protocol error for the WS connection. And we're going to handle that message, which is going to take a mutable reference to self. And it's also going to have that message itself, which is the exact same signature as this up here. So we can just save some time and copy paste that instead of retyping that all out. And we also get the context again. So because this ws : message is an enum, all we need to do is match on that message, and that'll be the whole function. If it's an OK, and if it's a ping of a message type, we want to reset the heartbeat, because that means that if we actually got a ping, that means the client is alive and it pinged us. So we want to self.heartbeat is equal to. So we reset that heartbeat interval because we know the client is alive. We also want to do the correct thing in the WebSocket protocol, and that is just to pong them back. So if they send us a ping, we just want to pong them with that same message. In a lot of WebSocket clients, this thing is handled automatically, but I don't think it takes up too much time to handle it like this explicitly. Just a quick little thing. This will be in almost all your WebSocket implementations. Okay, we're now going to see if we get the pong back. And this will be the response to our ping to the client. And we actually get the message. If you really want to be super strict, you could check if the message is equal to the message that we sent. But we're not going to have to worry about that right now because this is just a high-level overview. So we're going to just reset the heartbeat the same exact way we did it up here. Okay, the other message that we can respond to is a binary message. And it's just going to take that binary. All we're going to do is just pass it the context. And maybe the WebSocket context knows what to do with this binary. If it doesn't, it'll just void it. But we don't have to worry about this one at all. If we were coding something that did want binary, then maybe we would want to look into this and see what we can do with it. But for this implementation, we're just going to be sending text, so we really don't care if we get binary. We'll just pass it to the context. If we get a close message, this gets a little bit interesting. We want to take our context and we want to close it. And we want to pass that reason, because just because maybe the context cares why it got closed. But we also want to just force the context to stop. And that'll trigger this stopping method, which will send the disconnect message. And this one is a little bit silly how we implement it here, but we're going to do it like this anyway because I don't want to have to worry about continuation messages. In the WebSocket protocol, if a message is too long to be sent over WebSocket, it gets sent as a continuation frame, which is a continuation of the previous message, and you might need to explicitly handle that. The WebSocket package has a little bit of a handler for that, but we are not going to worry about going into there. We're not going to be sending beefy WebSocket messages that really care about continuations. So if we just get that, I'll just say stop. You can do whatever you want here. You could pass. You could not care. I'm just gonna stop. If we get a no op, we're going to do nothing, exactly like the no op tells us to do. This conforms 100% to the WebSocket standard. No op just means don't do anything. This one is where it gets a little bit interesting. if we get a text message, we want to take that lobby address of ourself. We want to do send a client actor message with an ID of self.id. Again, we need to notify the lobby who is sending them that message, the message of S, and the room ID, which is self.room. So all that happens here is we get a text message, and the S is the string. Sorry, we take our own lobby and we send them our message. And if we get an error, for this example, we'll just panic. You might want to stop the WebSocket in the same way we did here. You might want to log it for some reason. This will handle that. And that you could see that we actually exhausted this message. All the different enum types are completed here, and we handle them all. Finally, we need to handle the WebSocket message itself. So we need to implement a handler. This is how you respond to that mailbox message. You do the message type, which in this case is a WebSocket message, for the actor, which is a WS connection. So this means that every single time we get a WS message in our mailbox, we're going to respond to that message with this handle method. And that handle method is going to take a mutable self and a message that is a WebSocket message. It's also going to have the context that we have had in all the other lifecycle methods. This is actually a WebSocket context because we defined it up here as a WebSocket context, but we don't really need any WebSocket functions here, so we can just say regular context. One other thing for these handler messages is that we actually need to make a type called result up here. You'll see later when we define these messages, we have a return type on them, and we need to actually return this return type. But for this case, we don't care about our return type, so it'll just be void. And that means, but say, for example, it was a string on this message required a string return type. Then if we did type result equals string, we need to return a string from this method. And that means that if we did a send instead of a do send, and we awaited on it, this would return that string. But in this case, we are not returning a string, we're just returning nothing. So it's safe to just not return anything from here. All we do is we take that context and we send it a text frame, and it's going to be a message.0, which is going to be the inner element of that message. And boom, it all cleans up. All our errors are fine. This error is fine. Now we handle that WebSocket message. And there you go. That's your whole WebSocket handler. The next thing we're going to do is we're going to be writing those messages that we talked about. So we're going to create a file called messages.rs. Is that how you spell messages? I sure hope so. For the message passing file, we're going to need these imports, and like always, we just need to mod it. Mod messages. Now we have a valid file that we're going to look into. And we're just going to define all these messages. First up, we're going to have a derive the message, and that just tells the actor framework that this is actually a message, a struct that's a message, and we can do the different things on that on this struct. The R type needs to coincide with this R type, and in this case, we're going to do a empty one, but you could do whatever type of variable you want. Maybe you want a string, maybe you want some sort of enum, maybe you want whatever. The reason why this R type is here is because maybe we want to return something and we want to await on it. Then if we awaited on that message, if we waited for that message to be read, then this message would return whatever R type it is. But in this case, we don't care about the R type, so we're just going to say result is equal to nothing. You could put string in here if you wanted to do a string. You could even put I32 or whatever you want in there. In this case, it'll just be a regular struct in function form that just takes a string. And that's it. That's how you define a actor message. It's that easy. This WebSocket message only carries a string, which is just going to be the text inside of it. But for this next one, we're going to copy this because it's going to be the same thing for every single message we define here. But for this, we're going to just define the R type as nothing, and we're going to make the struct, and we're going to call it connect. As you can see here, we already used this connect one. It's going to take address, lobby, and self ID. So we just need to put those things in here. Public address is a recipient of a WebSocket message. Public lobby ID is a UUID. Public self ID is also a UUID. And that's that connect one. I'm just going to go ahead and copy paste the other two because they follow nearly the exact same form here. Let's delete these comments just for a little bit extra documentation. But I'm going to go ahead and explain them. The disconnect message only takes a room ID and a UUID and a personal ID to tell the lobby that, hey, I disconnected from this room with this ID. And the client actor message takes the message, the room ID, and the ID. And that's it. That's all we need here. Finally, we're going to be implementing the final actor, which is going to be lobby.rs. Again, here are the imports that we'll need. Our lobby, again, will just be a regular struct, pub struct lobby. And we'll have some sessions, which is just a hash map of UUID to socket. And then we'll have the rooms themselves, which is hash map of UUID to hash set of a UUID. In this way, we could just say to access any ID, we can just go into that room and then access that ID through that room. And if we want to send the message, we have to take the socket, which is actually a type alias that we define, which is just going to be, just so we don't keep writing it out, type socket is equal to recipient of the WebSocket message. So that means that we can send it a WebSocket message. Now we're going to implement a default, which I'll just copy paste because we don't really care about this. It's just basic Rust. And we're also going to implement a little helper function that I'm also going to copy paste. What happens here is we're taking a socket recipient. So this is just a helper method that just takes our socket recipient and we just send it that WebSocket message. This is just a quick little helper function. So instead of having to write all this code every single time we want to send our socket some message, instead we just pass the message, the ID, and we send that message on its own. Now we have to make this lobby an actor. So we implement the actor trait for the lobby, and we need to define that type context, which we will just do a generic context because we don't have any special functions. This is just a basic actor. And that is actually it. This is the only code we need to make this an actor because we really don't care about any lifecycle, because for the lobby, we're going to mount it on the application startup. And when the application stops, that's it. Our lobby's gone. There's no other application lifecycle for this lobby. So we really don't care about any functions in here. For the remainder of this lobby code, we're just going to be implementing the different handlers for those messages. For instance, in this case, we'll be implementing a handler for the disconnect message for lobby, of course. And we're going to type result. Well, this needs to be the same, so we can look back here. What was the disconnect result? It's going to be nothing. So we can just say nothing again. Function handle. Again, we know that signature by heart now because we've done it so many times. And the message is just the message that we're handling. And then we have the context, which we don't care about, but it is a mutable reference to self. And again, maybe we want to do that just to be explicit, but that is what we're returning. We're returning this result here. So we're going to say if self.sessions.remove at message.id, because we're saying that this ID disconnected. If it's something, then we want to self.rooms.get the room ID. We'll just unwrap here because we don't want to go through all the error handling in this tutorial. And we'll iterate through all the connections in that room, or I should say connection ID, because like I said up here, we get the rooms, which is a hash map of UUID to a hash set of UIDs. So we are iterating through the client IDs. And we'll add a filter onto this iterator that says if the connection ID is equal to the connection ID dot to own, because we have some references here. If that is equal to the message ID, we don't want to send that message because we already removed it. And why would you send the client that just left that you just left? So we're going to add that little filter here, and we'll just add some enters so that we just look a little bit prettier. We'll also dot for each on that, and then we'll actually iterate on the user IDs. And for each user ID, we'll self.send message, which is that helper that we wrote up here. We'll do a reference to a format string that just says blank disconnected. We could use usernames here, but for this example, we're just using UUIDs for all user identifiers. And we'll just take the message ID, and we'll comment here, and we want to send this send message to the user ID that's here, so we'll just say user ID. That's all we care about here. So just to recap, what happens is we just send a message to everybody in the lobby that this guy disconnected. Now in here we also want to say if let some lobby is equal to self.rooms.getMute get mutably message.room ID. So if this room actually exists, which it should because the guy just disconnected from this room, but just in case it doesn't, we just want to have this if check here. If the lobby has greater than one person, then all we want to do is just remove this person from the lobby. But if that person is the only person in this lobby, the person that just left is the only person, we just want to remove that room entirely. There's no point in having an extra room in the hash map if somebody just created that room with that. If somebody created the room with a UUID and then left, why would you have that UUID just sitting in the room with nobody in it? So we'll just remove it by just removing the room. And this is the reason why we need it mutably, because we want to remove that room. And there we go. That's this whole function. That's how we handle that disconnect message. Next up, we're going to be handling the connect message. As you can see here, the actor framework is just a bunch of handling messages. So we're going to be handling the connect message for the lobby again. And type result, like we said earlier, it's just nothing. You can look back and check if it's nothing, but it is. I promise you it is. And we're going to do the same exact signature here, except the only difference is it'll be for a connect method message. So first up, we want to create that room if we need to. Otherwise, we just insert the guy into the room, which is really beautiful, if you ask me. Message.lobbyID, or we insert with a new hash map, or a hash set, sorry, and we insert message.selfID. So what this does is we either insert a new lobby, or we go get that old lobby, and then we just insert the person into that lobby. Note that this is just inserting the UUID in that hash map. We just have not yet inserted the person into the session, which is the actual way to send the messages. Self.rooms.get at message.lobbyID. So this just gets the message lobby ID. And we can unwrap here because we promise that this message actually, this lobby ID does exist because we just inserted it. Now we can iterate through all the people in the lobby, just like we did earlier. We want to filter, just like we did earlier, connection, ID. It might actually make sense to add a helper method here. If you want to go ahead and do that, it's all up to you. because we are repeating the same code block a couple times. But here, we send a message to everybody in that room that, hey, this person just joined. And to do that, we just need to do dot for each connection ID self.send message. And that's going to be a formatted string again that says blank just joined. And the actual ID is just going to say message.self ID. And it's going to be to the connection ID that we just got. Again, we don't want to send to ourself that we joined like this. First of all, because we actually don't exist in the hash map yet. Because we haven't inserted ourselves into the sessions map yet, which we're going to do right now. We're going to say self.sessions.insert just ourself message.self ID and message.address. All we need to do is send to ourself the message that we just got an ID. So we'll just say your ID is blank, which is actually the ID that we got assigned. An ID to the same exact at message.self ID. We just add a semicolon here for no reason. And what we do is close that lobby handler, and we are good. We just responded to the connect message. So this is some kind of concise and beautiful code, in my opinion. We create a hash set or add ourselves to an existing one, and then we send everybody in the room that the person just joined. We insert ourselves in the session, and we say your ID is whatever your ID is. Finally, we need to implement the actual messages, because as you can see here, every single time we get a text frame, we tell the lobby, we give them a client actor message that we'll copy here that has the message. So what we need to do here is we need to implement a handler for the actual message for the lobby. Type result, again, same exact type. We need to handle. So now we can handle this message and send it to whoever needs to receive that message. We're actually going to have a whisper functionality. So we're going to say if this message actually starts with, we're going to escape this W. So in this case, if a client sends a message that says \W to the UUID, we'll just pretend that's the UUID. We're whispering to this UUID, this is a secret message. So in this case, we just want to send just that person the message. So what we can do here is we can say, if we're whispering, we could say if let sum ID2 is equal to the second element in this, because we can split on the string. We can split on the space character, so we say not the first but the second dot get 1. So if the second one is a value, then we can send the message, and we could say, we could just send the message to the UUID, but in this case the ID2 is actually just a string. So we want to send them, we want to parse it into a UUID. This is actually not type safe. This is actually a quick and easy way that somebody can break your application. If they just did /w, anything that's not a UUID, this is going to break, because this UUID parse string is just going to be unwrapped, and we'll panic here because, so you might actually want to check if this is a valid UUID, and if it's not, send the person back a message saying, hey, your whisper couldn't be delivered because it's not a valid UUID. But otherwise, if it is not a whisper, if it doesn't start with a secret message, it doesn't start with /w, do self.rooms.get at message.room ID, and you can see here that this is actually becoming quite repetitive. We've done this over and over. We want to send it to everybody, and we won't filter on self because we want the person to see their own message. And we'll just send that message, which is just the end message.message. And the ID too will just be the client. This client that we just said. And that's it. Now, if this client sends a message, then we're all good. We get that message to whoever needs to be delivered to, whether it be a whisper or it just be a whole server-wide message. Now, finally, we need to allow people to actually create this connection. And how we're going to do that is we're going to create a route called start_connection.rs. This route's going to have some imports, like always, right here. But we're going to do, it's going to be a get route. And all it's going to be is just a \group ID. It'll be an async function because it needs to be a route. It'll be a start connection. We'll take a request, which is the HTTP request. The reason why we need this is because to upgrade the request, we need to do some stuff on this HTTP request. Because we're using the WebSocket library, we don't need to upgrade this request on our own. The WebSocket package will do it for us, but we do need that request. We also need the stream payload. We need the path, which is the group ID. This will just be a path parameter, which is a UUID, which is why we need Serrated in our cargo.toml. And we also need the actual lobby, which we'll actually get from shared data from Actix Web. And in this case, we will return a result, which is either a HTTP response, which is going to be saying that, yeah, we upgraded the connection, or an error. And that error is going to be from Actix Web. So you can import it as an as if you don't like that it just says error. This is actually going to be a really tiny function because we just say let WebSocket is equal to a new WebSocket connection. It's our helper coming in clutch with the group ID and a server.getRef.clone because we need the address of this data, and because the address is clonable, then we can just clone it and we get the exact same. It's a clone of the reference, not a clone of the lobby itself. And now response is equal to WebSocket start WebSocket, the request, and the stream, which is all stuff that the WebSocket needs to start. And then we just OK on that response. And if this fails out, then we'll just question mark it. This will happen if we said back here, if for some reason we can't start the WebSocket. So this stops and it errors out. Then we'll send an error through here. Just some quick fixes here. I have a little bit of errors. We don't want this here. We want that here. This actually needs a connection ID. Just a little bit of silly errors. Oh, and here I forgot to collect into a type of vector of @string. And this needs to be ID too. Oh. And that's it. That all works perfectly fine. We can just save our files here. And now we can go into our main, and now we can actually spin up the server. Remember that we actually need to register the lobby in the data. That is because we use the lobby here. So we just need to mod some stuff, and I will just copy paste the imports in again. And we just need to make sure that we tell Actix Web that this is the Actix Web main function, which means we actually need to return a standard IO result. It should be nothing. And then we also just need to make sure that we say it's async. We save here, and it should work perfectly fine, except that we have not returned nothing. We have not okayed on nothing. So we actually need to create a chat server So how do we start an actor? The same way we did it with the WebSocket, but this time we can just default lobby dot start. That is how you start an actor. Dot start. It's that easy. Now this actor is listening for messages, and he's spun up, and he's waiting for any messages to get placed in his mailbox. Now this is all just basic Actix here. We create a new, we need to move that into this callback. App : new. Now we need to register the start route. We also need to register this chat server. And we'll just clone it for convenience. And then we .bind to whatever port we need, which means we're going to just bind it to localhost for this example. And if that doesn't work, we'll just error out. But we'll run, and that's all good, and that's everything we needed. So if we just do cargo run, our server is spun up. And that's it. That's the whole WebSocket client. Thanks for watching, guys.